Hi AP. Okay, I've picked out an old AP question that involves taking some, in this case, quadratic data and making it into a linear function. So this happens to be from 2006, but this happens pretty often. So here we have some distance and force data. You don't need to know like the context too much right now, but they say to assume that the magnitude of the force is of this form, basically that it's a quadratic function, and you can see that basically in the way the numbers are going up. If you graph it, this is me graphing it. You could do that if it was the AP exam. You could quick plot it on your calculator just to double check, but they're telling you the function, so there's no need to do that. So the first question is, which quantities should be graphed in order to yield a straight line whose slope could be used to calculate a value for A? We're looking for this coefficient right here. And since everybody can calculate slope of a line, that's this process of linearizing, making something into a line when it's not. That idea is basically like if you didn't have a graphing calculator, this is what you would do. So the process for doing this, okay, is to graph two quantities that would have a linear relationship. So since we assume that this is the relationship, there are two right ways to do that, right? So basically we have y equals ax squared. So we can either do y and then put the quantity x squared on a new x-axis, okay? Because then we would have a new function, like, say now z stands for x squared. Now y and z have a linear relationship, okay? Or if we solve this for x, we would take the square root of both sides. And then we could have square root of y equals ax, okay? So then we would have a new variable that we would be graphing on the y-axis, y prime, you could call it. So now we'd have y prime equals ax. So there are two right answers to this first question. You can either graph square root of y and x on the same graph, or you can graph, square root of force and x, or you can graph force and x squared, okay? So I don't know, I guess I'm gonna choose to square x. So what I'm gonna do on my graph here, I can just delete this one, it's not useful to me. I can scoot this over, so I'm just gonna move my y-axis over. It seems like Excel and Sheets doesn't like to have the y-axis come first when you're making the scatter plot, so that's why I'm moving that over rather than making a new column to the right. And I'm going to call this x squared just so that I remember what this is, and make sure I square the units, because when you answer questions about what this quantity is, often it will ask you like when it asks you for the slope later on, which is a question, you need to include the units, so you don't want to forget what the units were. And then often I have the Excel or Sheets do the math for me, so I put an equal sign here and I have it calculate this quantity for me. So I do that cell times itself, and then I copy that formula down again, what I do is I take this bottom corner here and I drag that with my mouse. Okay, so that copies the whole formula down. And then I'm not trying to do that on my calculator. That's what spreadsheets are for. Okay, so now I'm going to make a new scatter plot of my new information so that I can graph that. Make this visible to you. And now I'm going to see that this looks linear. Shrink this down where you can see it. And if I put a line with it, hopefully I'm going to get an r squared that's very close to 1. So if I fit that trend line and show the r squared value, wow, look at that, it's 1. They gave me data that was really nice. And I get a really large coefficient for A here. So then I've gotten my value for A. Okay, so then that isn't actually the answer for part A. The answer for part A, which quantities should be graphed, then I should be typing here force and distance squared, or square root of force and distance. But then later on it asks for all these, it asks you to graph it, asks you to plot a best fit line, and on the AP exam you would be actually using a ruler and drawing it and doing slope calculations. But when we do labs in AP, I'll have you do it on a computer, since we have the power of computers available to us. Okay, so then I'm going to pause it and do an example of an inverse function. Okay, here's another example where we are going to linearize a relationship to find a constant. So in this experiment, my students studied the relationship between acceleration and the total mass of an object, and they changed the mass on purpose, but they kept this variable force the same the entire time. So this force should be a number, and they're checking to see if this relationship holds Newton's second law. So here we expect this mass to have a power relationship to be A equals F times m to the -1, basically. If I graph their data, I get kind of doesn't look quite right, but it's an experiment. There are outliers. So if we were going to see this on an AP exam, they would want us to linearize the data. If on the lab report, though, I had them linearize it on Google Sheets or Excel. So let's do that. Let's take this graph out and let's insert a column and just do basically mass to the -1, reciprocal of mass, okay? Because then what I'm doing is I'm basically saying I'm going to make a new variable called 1 over mass, and that's going to be my x. That way I'll have A equals Fx, okay? So then that I can find what F is, for example, and I can verify whether this is truly the relationship I think it is. So now I'm going to have my x column equals 1 over total mass, okay? And the units for that are 1 over kg, which is a strange unit, okay, but that's okay. And then again, I can have the spreadsheet calculate that for me, 1 over that column. Copy that down. These numbers, instead of getting larger and larger, should be getting smaller and smaller, okay, as because they're reciprocals. And then let's plot that. So I'm going to insert my new scatter plot. And I do have that weird outlier there. So I'm probably not going to get a great R-squared value. And let me move this where you can see it better. Okay. So now in my linearized version, if I put my trend line in here, okay, then I have like a strange y-intercept value. The R-squared value is not great. I might decide that I don't like the first data point, but on the other hand, it's not that much worse than the others when I look at how that line fits. Okay, so now I can decide, well, how does this coefficient in front of my x value, where x is 1 over m, that's supposed to correspond to the force, and I can look at my experiment and decide, does that make any sense with respect to my experiment? So that's how we linearize. That's what that made up word is supposed to mean. And now I'm going to have you do some practice with that process.